Hi there, welcome to Unit 7 Learning Target. I can graph exponential functions. So the first thing we need to do is establish what an exponential function is. So, an exponential function has the form y equals a b to the x. So y times b to the x, or also like f of x equals a b to the x, which you've seen before in function notation. You've seen that before. Probably our worksheets are going to focus a little bit more on this form right here. Okay, so things that you need to know. X, as always, is our independent variable. Independent variable. Y is the dependent variable. Okay, A is our y-intercept, also known as the start value. And B is the growth or decay factor slash decay factor. Okay, so now that we know all of that, our learning target today is I can graph exponential functions. So this isn't really anything new, things that you haven't seen before. It's just graphing. So we have a graph here. Let's say we have the function y equals 2 times 3 to the x. All right, so while fundamentally I understand 2 is the y-intercept, or the start, when x equals 0, and 3 is the growth factor. Let's see how that plays out, though, in a table. Because really, I'm going to make that table a little bit further over. Here we go. Really, that's probably how we know the go-to for graphing works. If we make a table, we can see what this information is doing. So let's just do -1, 0, 1, 2, and we'll see. I think that's enough points to see what this graph is doing. So when x is -1, well, we've got y equals 2 times 3 to the -1. Well, great news. We know what 3 to the -1 is. We're going to move that down. That becomes 2 over 3 to the first, or just 2 over 3. Okay, we have x is 0, so that means we have y equals 2 times 3 to the 0. I know anything to the 0 is 1, so that's like 2 times 1. That's just 2. When x is 1, y equals 2 times 3 to the first. Well, 3 to the first is 3. 2 times 3 is 6. And the last one, y equals 2 times 3 to the second. Whoa, well, 3 to the second is 9. That's 2 times 9. That's 18. That's like way off of our graph. Okay, so remember, each of these is an ordered pair. It's an x and a y, comma, ordered pair. So when x is -1, let's do this in green. When x is -1, y is 2/3. So that's in between 0 and 1, a little bit closer to 1. Okay, when x is 0, that's on the y-axis, y is 2. When x is 1, y is 6. And when x is 2, y is 18. That would be like way up here. So this is not a straight line. These graphs come through, and that really should have connected there, but have a curve to them. Okay, so these will not be a straight line. Okay, let's look at one more of an exponential. So this was a growth factor, and a little bit of summarizing afterwards. Okay, let's say we have kind of the opposite of what we had in the last problem. Let's say we have y equals 3 times 1/2. Or we could have it in parentheses to the x. Okay, so again, I'm going to make a table, an x and a y table. Let's say I have -2, -1, 0, and 1. So for each of these, I'm going to plug in the x in place of the x right here and see what we get. So y equals 3 times 1/2 to the -2. Well, that would be like 1 to the -2 and 2 to the -2, which is really the same as 2, like 3 times 2 squared, because we'd have to move that up. That's 3 times 4, that's 12. Y equals 3 times 1/2 to the -1. Well, let's see here. That's like 3 times 2 to the first, that's 6. Y equals 3 times 1/2 to the 0. Anything to the 0 is 1, so that's just 3. And y equals 3 times 1/2 to the first. Well, 3 times 1/2 is 3 halves, or 1.5, if it helps you to think about that. Okay, so as we graph, -2, way up here at 12, I'm going to put like a point up there. That's where it would be essentially. That's like not what I wanted. Okay, -1 is at 6, 0 is at 3, and 1 is at 3 halves, or like 1.5. So again, we can see that this is kind of a curved graph. Okay. Okay, in our exponential function, y equals a times b to the x. Okay, really important. If b is greater than 1, it is a growth function. So your numbers are going to be getting bigger. Okay, on a graph, that looks like this. Okay, so your numbers get bigger as your x's get more and more positive. Okay, if b is less than 1, but it has to be greater than 0, it is a decay function, which means your numbers get smaller. So on a graph, a quick graph, this is going to look like that. Okay, your numbers get smaller. As x's get bigger, your numbers, your y values get smaller. So as the input gets bigger, the output gets smaller. Okay, here's what I want you to do. Write a summary. What did you learn about exponential functions? And bring that to class. I might ask you to share it. I might ask you to put it on a piece of paper and turn it in to me. That is it. Have a great evening.